Okay, good afternoon, everybody. My name is Stefan Magnus Landrø. I'm going to talk about Terraform today and also about how to colonize Azure using it. So, Terraform, what is it? It's a command line tool written in Go. So that basically means it can run on pretty much any platform that you can imagine. So it runs on OS X, which I'm going to use today. But you can also run it on Windows, Linux, pretty much any operating system. It's a tool that's being actively developed by a company called HashiCorp, which is famous for other DevOps tools like Vagrant, Packer, Console, Nomad. Nomad is a recent addition. It's a container scheduler, so you can do Docker containers and stuff like that. Packer is used for building OS images. Console can be used for service discovery kind of stuff. Vagrant, I guess you all know Vagrant. So what can you do with Terraform? You can basically describe and define infrastructure as code, and that is cool stuff. And you can use HCL formatted text files to do that. And HCL we'll see lots of examples of HCL syntax. It's similar to JSON, just way easier to read for a human. And you can use Terraform to do stuff like provision servers, networks, load balancers, whatever. Stuff that you find with all the different cloud providers. And the cool thing about Terraform is you can actually combine and use different cloud providers in one big infrastructure. And we're going to do that today, because this is going to be a massive live demo, really. And I'll be launching a couple Linux virtual machines at DigitalOcean, which is a cloud provider in, well, they're worldwide, but I'm going to launch them in Amsterdam. Then I'll mix in some DNS with Amazon, and then create a DigitalOcean similar setup over at Azure in Ireland. So I'll be launching Linux machines and starting Apache, which is a popular web server. Okay. So what is Terraform and how do you use it? So a provider is the provider concept is probably the most important concept in Terraform, and a provider lets you talk to different clouds. So you can use one provider to talk to AWS and another one to talk to, let's say, Azure. And there's lots of different cloud providers that you can use with Terraform. Pretty much all the major ones. And the provider shields you from the underlying details of the APIs. So you don't really have to know the internals of, let's say, the REST API of Azure, enabled to use Terraform. So let's have a look at some code. So this is how you configure the provider that lets you talk to DigitalOcean. I'm using IntelliJ, which has nice HCL support. And this is basically it. So this piece of code will let me talk to DigitalOcean. I can use code completion functionality in the editor. And I could have used my secret key in here, but I'm not going to do that today because I don't want you folks to hack my account, right? So I'm keeping my secrets secret from you, and using an environment variable instead. And the way I'm going to apply now this configuration to DigitalOcean. So let's get into the command line. So the way you use Terraform is you'd start out by running a dry run, sort of, which is called a plan in Terraform. So let's see if everything is correctly set up. Yes, I'm all hooked up with DigitalOcean now. But I haven't defined any resources yet, and it's all up to date. But there is nothing to do, right? I haven't configured anything yet, except from the provider. So let's have a look at, I'll just perform a quick code update here, and let's look at some at the second most important concept in Terraform, which is called resources. So resources are actual things that you can provision within a cloud context. So that could be things like a virtual machine, IP address, pretty much anything, right? And the name of the resource is a combination of the provider name, which is used as a resource name prefix, and a unique ID is being, you have to have a unique ID based on the resource name and a ID you specify yourself. And that's not going to be the unique ID that you typically find within the context of a particular cloud provider, but locally in your Terraform configuration file. So let's have a look at that. This looks like this in code. So here I'm going to upload my SSH key. I guess you all know SSH keys? If you come mostly from a Microsoft background, that's maybe not what you use all the time, but SSH keys are basically public-private keys that you can keep in a file, which I'm going to do here. And you typically share your public key with whoever you want. So I'm going to upload that to my cloud provider. And I'm keeping my private key private because it's a private key, so keep it private. So let's try and generate this resource with DigitalOcean. So as we can see here, by the way, this is the prefix of the resource type. It reuses the name of the provider, okay? And the combination of this and that has to be unique within my Terraform configuration setup. And so this keyword here file will actually load my public key from the directory where this file is sitting. Okay, so let's run a plan again and see if Terraform wants to do stuff. And it wanted to do stuff, but my SSH key is missing. So I'm just quickly gonna generate an SSH key. I'm not using a passphrase. And so I now have I have a public key sitting here in this file and a private key sitting in this file, okay? So nothing spectacular about that. But then I should be able to do a new plan. And Terraform will tell me that it wants to generate or provision a SSH key resource with DigitalOcean named SSH. Okay, that's the idea of my resource. Okay, so let's actually provision that and upload my key. Should be quick. So that was it. So that just uploaded my SSH key to DigitalOcean. Nothing spectacular, nice and fast. I'll quickly kick off a Terraform apply in the background because this is a live demo and things take time to provision sometimes. Okay, so dependencies in Terraform. You can define dependencies between resources in Terraform. And a resource can therefore depend on another resource, and that will also determine the order of creation. So if a resource depends on another resource, one of them will be created before the other one. Now I already have my SSH key in place, so I can actually depend on that right here when I generate a droplet resource here. And a droplet is basically a virtual machine, okay? It's a virtual machine. They call them droplets. I don't know why. It's a virtual machine. And I'm going to use the CentOS image, which is a Linux distro. They support all kinds of distros, and even Microsoft stuff. So they have a huge selection, and you can even use your own images and generate them using, let's say, Packer or whatever. And I'm going to launch my server in Amsterdam. And it's going to be a pretty small VM. And that's about it. So that should be, let's see what happened in Terraform. So Terraform just applied the change, and I have a server running in Amsterdam. So where is it? I don't know where it is, right? Because I don't know its IP address. So, well, how do we sort out where the IP address is, or what it is? So that's where the Terraform show command comes into play. So whenever you perform a apply, the tool will save its current state in the cloud in a state file that you can keep locally, or you can keep it in the cloud. All right. So where the configuration file tells you, or where you in your configuration file you describe the state you want, and in the state file you have the actual state in the cloud. All right. So it's two different things. And you can keep the state, let's say, locally or in S3 or console. And there is support for stuff like locking. So that's kind of cool. So I can apply changes to my infrastructure at the same time as someone else is applying. And, well, this will all work out nicely. You won't get conflicting changes. So that's kind of nice. So let's find that IP address. So here it is. So the Terraform show command gives me the contents of my state file in a readable format. So this is the IP address, and I can actually log into that now using SSH. Up. So the IP address probably changed from last time I did this. So this is it. I'm connected to my web server in Amsterdam. It's a Linux machine, up and running, nothing spectacular. You can see they put the name of the instance in the prompt, so that's kind of nice. So let's just kick off one more transformation, or apply. Hang on, what was that for? Yes, so I'll kick that off in the background. Apply. Okay, so that was Terraform show. Syntax. Terraform is, it provides you with a rich expression language. You can do stuff like variables, you can do string interpolation, you can do, they provide you with lots of basic functions for doing math, for doing base 64 kind of stuff, hashing, security, things like that. You can do join operations across lists, you can do lowercase, uppercase, etc. Basic functions like that. And there's also support for a special keyword called count, which lets you define the number of instances of a particular resource, which is kind of nice because then you can easily scale up and down your infrastructure. We'll see an example in just a few secs. And stuff like environments, if you want to have, let's say, a production environment and a testing environment, etc., you can use the functionality is basically built into native syntax in Terraform. I'm not going to demo that today, but you can easily do that. And Terraform also supports stuff like modules. So you can define modules that will define infrastructure that you can reuse across, well, what have you, really, you can use it for pretty much anything. So they're pieces of code that are reusable, just like any other reusable kind of software. And that also supports versioning, which is kind of nice. And that's all Git-based, so it's really cool. Let's see. So let's look at some code. Here's my code. I just defined a couple of variables. So I created one variable for holding the number of web servers that I want to create, and a variable for holding the name of the data center I'm going to use. In case it fails, I can easily switch to another one. Okay, so that's kind of nice. And here this time I'm gonna use the count keyword for defining a variable number of servers. And so in this particular instance, I'm going to define 2, right? Because the value of this variable is 2 right now, okay? And I'm going to use string interpolation for generating my name. So I'm going to call one of my servers web0 and the other one web1. So that's about it. Let's see what happened. So the existing web server just got renamed from web to web0. So that would be an incremental change, right? To my infrastructure. And after that, a new resource gets created. And that's about it. Okay, so I now have 2 web servers sitting in Amsterdam instead of 1, and I just renamed one of them. Let's see what this interface is telling us. Yeah, so two resources. One got created 7 minutes ago and one 3 minutes ago. And we can actually see the IP addresses here too. So let's kick off some more transformations to our applies. Kick that off in the background. Provisioners. A provisioner lets you provision on top of your resource after it's created or right after creation. And Terraform supports, it has native support for Chef, which is similar to Puppet and Ansible and tools like that. But you can also use the remote exec provisioner to run let's say a bash script on the remote machines right after creation. Or you can have Terraform run or execute a script that you run on your local machine. So you could kick off, let's say, Ansible. Okay, so let's have a look at some code. So here it is. I'm going to install Apache using the remote exec provisioner. So because this is all on CentOS, I'm going to use, or I have to use Yum to install Apache, which is this software package, HTTPD. And I'm going to give it SSL support, and I'm going to enable the service. So it will restart automatically on reboot, and I'll start it up. And to provision, I'll be using SSH, log in as root, or well, Terraform will log in as root. And it will be using my private key to log in as root. Okay. So let's see what happened in Terraform. Well, guess what? Nothing happened, and that's because, so why is that? That's because the resources already existed, and there's no support right now in Terraform for applying provisioners after math. So you have to provision as part of, or the provisioner will only run while you create the resource, okay? Right after, so this was too late. So that's where this tool comes, or this command comes in handy. So every time you have to recreate a resource from scratch, you have to taint it. So it will be deleted and then recreated from scratch, and the provisioner will run. So let's run that command. Taint. I'll taint my 2 servers. And then I'll kick off the Terraform apply command. So what happens now? First thing that happens is that Terraform will destroy my existing instances. Okay, so this is pretty quick. If you compare this to Azure, DigitalOcean is way faster. Okay, you can see it yourselves. It takes 10 seconds to delete an instance, and it should take around 40 seconds to launch new instances. So it's much, much faster and much more demo friendly. So that's why I'm launching or starting out with my setup over at DigitalOcean. I wonder why Azure is so slow. This is okay. So Here you can see my instances got created, one of them in 30 seconds. And now Terraform is trying to connect to my server using SSH. Let's see how that goes. So there it actually got connected to one of my instances. And then it's applying my provisioner on that instance. And these things happen in parallel, right? So I'm having one server being provisioned and the second one in parallel, and they're both downloading stuff from the internet and installing it and bringing up everything. So this is it. Hopefully should be pretty close to finished. Let's see. It's taking some time. Why is that? I don't know. So one of the instances is probably finished already, and the second one is being provisioned. Oh, there it is. So both up and running. So I can run the Terraform show command. It will give me the 2 IP addresses. I'll just click on one of these. It should show me, this is the welcome page of Apache. So Apache is running in Amsterdam. Okay. Yes, so this is all cool, right? But you might think, well, private keys, keeping them on disk on my machine, maybe not that secure. So this is where security matters, right? Cloud and security, it's important to keep these things secure. With great power comes great potential for damage, right? So keep your stuff secure. And I'm going to demo using my YubiKey for provisioning. Are you all familiar with YubiKeys? It lets you, basically it's a GPG smart card that you can use as an SSH key. So the private material is inside this thing, this hardware device. And my public key is wherever I want to keep it. So let's have a look at that. Now I'll have to taint my resources again because this time I'm reprovisioning with my GPG key. So this and that, and the code looks a bit different this time. Yeah, I'll just kick off the apply. Okay, so my SSH key is kept in GPG. I'm going to export that. Nothing crazy about that. So this is my GPG public key, which is matches the private key, which is inside this thing. So I'll just keep my YubiKey ready because the terminal will ask for it in just a few seconds. Okay, let's look at some code. So this code block used to include the name of my private key, right? Or the name of my private key file. And now instead I'm going to use the SSH agent. So that's why it says SSH agent true instead. So in a sec, a thingy should pop up on my screen asking for me to insert my YubiKey. So instances are being created. Well, they first got destroyed, right, as before. And before that, actually, my new SSH key was uploaded. Okay, so it got replaced with a new one. And the existing machines got brought down. New ones get created. So they're up and running in 40 seconds again. And now Terraform is trying to connect to my instances. And in a sec, it should prompt me or give me a box. Come on. There it is. I'll insert my YubiKey. I'll unlock it. What's going on? Oh, come on. Hang on. There it is. It will ask me for my PIN code. And this is a write-only device, okay? So you can't extract the private key material from my YubiKey. That's a write-only device. So you better keep a backup of this. So now I'm provisioning my servers using my YubiKey. And this is way more secure than keeping your private keys on file, right? Which is cool. And I highly recommend it. The device, it can be used, well, there are several companies selling devices like this. And most of them support stuff like this, so GPG. And you can also do universal second factor, okay, which is natively supported by browsers. So you can log into websites using it and stuff like that. It's really cool. Okay. Now I'm pretty I'm running Terraform show to get all the details of all my stuff is kind of cumbersome. So, or it's a massive amount of output, right? So I want to have it presented to me in a way that is more, well, easily available. So then I'm going to define outputs. So an output, the output keyword lets you define values that will be output when Terraform applies. And you can easily query the output, and we'll do that. So let's have a look at the code. So I've defined an output. So this will use the join method, which is part of the expression language. And it will actually join the two IP addresses that are part of this list in a string, comma separated. So let's do a Terraform apply, which will refresh stuff in the background. And so here it is. Here's the output. So I have well, guess what? I still have an Apache running, this time probably on a different IP address. I don't know. Could be. And I can also query that using Terraform output as either as JSON, like this, which is nice because then you can feed it into other tools, or just like this. So it's handy. Okay. Now I'm going to throw in some Amazon stuff. I'll kick that off. So the unique thing about Terraform is you can combine resources found with different cloud providers in one big infrastructure. Okay? That's pretty unique. You can't do that with the stuff that the other guy was just presenting before I came in here. So that's kind of cool. And it's unique. You can't do it with native tools from Azure, and you can't do it with the native tools that you find in Amazon. And you can't do it with stuff like Heat, that is a similar tool that you use with OpenStack. So this is pretty cool. It is pretty cool. And I use this particular feature every day where I work, because we combine different clouds in one big infrastructure. So here I'm, guess what, configuring the AWS provider. Okay, it's going to run in, well, I'm going to talk to EU Central. Now, it turns out DNS is worldwide, so it doesn't really matter. So things will propagate worldwide. And this is the name, or the DNS zone ID. I looked it up manually in Amazon because it just takes too long to propagate the name server changes with your registrar. So when you buy a domain name, it takes like a day to just get it up and running. So I did that a couple days ago. I just looked it up, this ID manually. Now, if you launch lots of new domain names every single day, you can use this resource instead. It depends on your business, what you're into, right? So I'm just creating a DNS record. I'm going to hook it up with my domain name called landro.io. It's going to be a type A domain name record. So that's IPv4, IPv4 addresses. TTL 60 seconds. I'm putting in the 2 IP addresses of my 2 instances. So that should be all up and running. So that was it. Amazon did that for me. So I should be able to use domain names now, which is cool. Let's see. Oh, there it is, up and running. I don't have to use domain name, IP addresses anymore. That's nice. Okay. Just apply that. Now now comes what you guys have all been waiting for, which is, I guess, is Azure, right? Now it turns out Azure is really slow to launch stuff, right? And I'm not very happy with it, to tell you the truth, but well. So you can do multi-provider, and you can do multi-data center, and you can do multi-technology, and you can combine all kinds of stuff in one big Terraform configuration. And now I'm going to use DNS-weighted record sets in order to direct half of the traffic to DigitalOcean and the other half to Azure. Okay, one half goes there and the other half goes there. And I use health checks in order to survive a data center or cloud provider outage. So in case, let's say, DigitalOcean goes down, I will still be able to handle customer traffic. Okay, cool stuff. Think about it. And it's quite easy. And I could have used, so this health check thingy, or that feature is, you find that only with Amazon right now, I think. And so that's a unique feature of their cloud. And you don't find that with Google or with the native DNS provider in DigitalOcean or in Azure. So that's kind of cool, because then you can pick and choose stuff from the best stuff that you can find with the best cloud provider and plug it into your infrastructure, and you'll get super happy, because you get the best of all clouds. Okay. So here I'm gonna start using Azure. I'm still keeping my secret. I'm going to use the public environment in Azure, so not the German one. I'm going to use the data centers in Ireland. And I'm generating a new resource group. And then I'm creating a virtual network in that resource group. So I'm depending on it here, right? Then I'm going to define a subnet, which is part of this virtual network. I'm going to depend on a security group, which is defined here. And this security group will allow inbound traffic on port 22 in order to let me provision stuff. And it will allow inbound traffic on port 80 to serve web content and HTTPS. And deny everything else. How are we doing in the clouds? Let's check it out. So as I mentioned, it takes time to launch virtual machines with Azure. It takes like 4 minutes maybe, as opposed to 40 seconds with DigitalOcean. So here I'm provisioning a couple IP addresses. So I'm provisioning actually 2 IP addresses. I'm then attaching these IP addresses to brand new network interfaces. That's happening right here. So where is the the IP? That's here actually. That's where I attach the IP addresses to my network interface. Okay. And in addition, I'm attaching my security group to this network interface as well. And then I'm going to put all of that inside a availability set because I don't want to go down all the time, right? And I'm going to use a managed availability set. So I want Azure to handle all of that for me, okay? I could have done this myself using, let's say, Terraform. It's just easier to do it with the managed availability set. Let's see what's happening in the background. So virtual machine is still being created. So this is my virtual machine, and it's a standard A2. I don't know really, I can't remember really what that means, but it's a nice little box. And this is important. This stuff. So this is the essence of DevOps, I think. You should never keep backups of your machines. You should instead delete them and make new ones, okay? So you don't get flaky servers. Just kill machines and bring up new ones instead of, taking great care of them. Never take backups of virtual machines. Take backups of your infrastructure code. I'm going to launch a CentOS image, so the same stuff that I'm using in Amsterdam. And here's my storage disk. And here is the name of my computer. And I'm going to be the admin, because I want to be the admin. And here is my console login password. And here I'm reusing my YubiKey down here. So this is Linux specific functionality. There is a similar code block for Windows. Okay, so this is taking time. Nice. So at least one of the servers is one of them is ready. That's good. But the other one is taking 6 minutes. Never did that before. Okay. And I'm going to run the my provisioner, just as before. And now the syntax is a little bit different because it turns out the templates that are provided by Microsoft or by this company, what's it called, OpenLogic, you have to use sudo to install stuff. But I'm basically installing the same piece of code as on the other boxes. I'm installing Apache again with SSL support. I'm starting it up. And I'm going to connect to it, or actually Terraform is going to connect to it using SSH as my user on these two public IP addresses using the SSH agent. And now comes the magic. So here's where I do I define a domain name for my Azure stuff, and down here I put in the health checks. Down here it is. Hang on, where is it? Yeah, here it is. So AWS will ping my servers to see if they're online, and that's about it, because this last block is the equivalent for DigitalOcean. Is this up and running? Yes. So I should now be able to, I now have a new domain name which is called www.landro.io, which is either directing traffic to Azure or DigitalOcean. And I don't really care as a customer if this guy is handling it or if this guy is handling it. Okay. So how does this work? So the health check is actually asking for this resource on my web servers to see if the data center is up. So right now, if I log into Route 53 at Amazon, let's see, should be all green. Yeah, they're both green. As we can see, DigitalOcean has been online for quite a while, and Azure just got online, so now it's healthy. Now, let's say DigitalOcean goes down. That would be interesting to see what happens then. By the way, you can do it. Are you guys familiar with this command? Dig? Yeah? Raise your hands. Yes. 1, 2. Oh, not that many. It's a utility to look up domain names. So it basically lets you query the IP addresses of your domain name. And as we can see, I defined a domain name called www.landrø.io, which points at a CNAME record. Either this guy, that's half of the time this, when I do a dig, half of the time I should get the CNAME alias, and the other half of the time I should get Azure. It tends to be, somehow, I don't know why, but tends to, Amazon tends to give me DigitalOcean IPs all the time. I don't know why. So this is, but this could depend on where you are. If you're in let's say Northern or in Ireland, you'd probably get the IP addresses of Azure. But this can basically, it should wait. The traffic should be going. Half of it should be going to Azure and half of it to DigitalOcean. But for some reason, we tend to get DigitalOcean mostly. Maybe they're just whoa, there it changed actually, as you can see. So that's kind of nice. So this just got switched over to Azure, and my IP address is completely changed. So if I hit this domain name again, it should be, oh, guess what? It looks the same because it's well, it's running at Azure. It's the same, right? So that's how you. So half of the traffic is going to one data center, and the other half to the other. Now let's take down. Let's take down DigitalOcean. Let's take down DigitalOcean. So I can log into my DigitalOcean servers by. Let's do that. So here's my DigitalOcean IP addresses. So I'll take that and log into it and shut down my Apache web servers. I'll just do this manually so you can see it. So system control. So that's how you shut down Apache. And then I'm going to do the exact same thing with the other IP address, which was this one, I guess. Hang on, 58.9. What am I doing here? 40. Yeah, this guy. So I'm just going to stop Apache like this. So now the two DigitalOcean servers have been brought down, and my health checks should start failing. Right? So let's just quickly refresh. Oh, it's still healthy. It takes, so this depends on your. It will take like maybe half a minute or something like that, depending on the frequency of your health checks. So this is probably going down pretty soon, and we can have a look at. So this should be. Where is it? Alarms, health checkers. So as you can see here to the right here, my checks are starting to fail because the connection is refused, and this should pretty soon be brought it will pretty soon be taken out of DNS. So unhealthy, DigitalOcean is unhealthy. And if I do, sorry. If I do a dig, I should always get a, I should always get the IP addresses of my Azure account or servers consistently, like all the time. So not just half of the traffic, all of the traffic should get directed to Azure now. Okay, let's see. I guess, yeah, that was the end of the code. We can have a look at this. So a Terraform setup can get pretty large, right? It can contain lots of resources. And that's where this command comes in handy. Because it will generate a nice little, well, it's not that little, it's just nice. Terraform graph. It's quite, just this tiny little setup will get quite massive. So, but this will actually tell you the order of creation of stuff. So my SSH key will get uploaded first because my droplets depend on it. And my droplets also depend on my variable, etc., etc., etc. And now the cool thing, I'm not going to demonstrate that, but if you use modules in Terraform, you'll get several of these graphs in the same picture, basically, sitting next to each other. And this is actually the name of my root module, which is called root. And here's my Azure stuff. So it's similar, just way more complex, right? It's not generating more customer value. It's just giving you lots of extra work to set up. So how about that, Microsoft? Yes, let's take that down. So, summary. Terraform is really great for defining infrastructure as code and evolving infrastructure, right? I've been doing that throughout this presentation. And I wouldn't do it if I didn't know it would work, right? So this is good stuff. And you can perform incremental changes easily, and you can version control them, just like I did, by using Git, or you can use any version control system. And the cool thing is you can, and again, what is unique about this is you can combine stuff from different clouds easily. You can't do that with resource templates from Azure or CloudFormation templates. If you're into, if you want to look at the code, you can find it on my GitHub account. It's all in there. You can follow me on Twitter if you're keen to do that. And if you're into this kind of stuff, come see me afterwards. My company is hiring. And, well, I'll take some questions. Yes?
If somebody changes something in the portal,
yes.
The Amazon portal or Azure, how does Terraform get noticed?
So the question was, what if someone, for some reason, changes something in the portal? So first of all, you should never do that. Because it's not version controlled. It's not version controlled, right? That's terrible. That is terrible. This is what DevOps is all about. Version controlling stuff. Writing code. Automating things. It gives you a higher level of security. A higher level of, well, uptime, I'd say. You don't get flaky servers. Okay? So don't do it. So prevent people from doing it using your policy files or whatever, depending on which cloud you're using, okay? Just don't do it. So, and if you do it, you can do it still, okay? So there's actually functionality in Terraform for importing resources and resource definitions. It's a feature that got added maybe half a year ago, so you can actually download the existing configuration from the cloud and save it locally. And actually, as part of now, if you do what you're if you really do what you're doing, you know, you shouldn't be doing that. But hang on, I'll show you something here. Terraform. There is this refresh command, which actually will look at the current state in the cloud and download it and sync it with your state. Okay, so this refresh will actually pull it down. Now, you can either run that manually after, you know, clicking around. If you spend your time clicking around, you can do it like this. And actually, refreshing will occur when you apply too, automatically. So if you perform an apply, it will actually perform a refresh first. As you can see, the current state is actually being refreshed when I perform an apply. So that's implicit. Yes, more questions?
Can you define your own resources that are not on the cloud provider?
Yes, can you define resources that don't exist already? Yes, you can, because Terraform is open source. So you can use it to define whatever you want. And people do that. Okay? People do that. This is all open source. It's written in Go. It's easy to, let's say, if you have some strange box doing, I don't know, whatever, it could be, you know, a webcam with a specific protocol of some kind, I don't know. You can implement the provider that talks to that thing. Okay? Or you could even provision, you can use Terraform to provision stuff inside your database. Let's say a database table, if you wanted to. So pretty much you can use it to provision resources in general. It's not only a cloud thingy. And by the way, I didn't show that yet, but you can. So Terraform comes with lots of stuff. And it's the open source community surrounding it it's pretty amazing. So these are all the, hang on, that was provisioners, providers. So this is, if you see in the left here, this is all the stuff, all the clouds that you can talk to. And you can do stuff like, let's say, if you use Grafana, you can have Terraform talk to your Grafana installation and configure it. So that could be, you know, defining, let's say, dashboards or things like that. I haven't looked into Grafana in particular, but you can do that. Oh, there's even an HTTP provider. I guess you can do HTTP calls somewhere. So that would be a provider to do, you know, make things glue together real nicely. Yeah, there's lots of stuff that you can do, right? And it's easy to add more stuff. Okay, more questions? Yes?
How would you handle like rollouts if changes are destructive?
How do you handle rollouts if changes are destructive?
Like if you do not incremental changes, it actually destroys the machine?
Yes, so if you incremental rollouts, so life cycle things. Is that what you're saying? Yeah, yeah. So let's say you have a the classic example would be you have a security group in Amazon, or autoscaling group or stuff like that. Autoscaling group, and you want to just get rid of it and bring up a new one that replaces the existing one. So you then bring up the new resource or the new autoscaling group, the new one before getting rid of the old one. And that's being handled, or there is functionality in Terraform for doing that kind of stuff. It's called life cycles. Yes?
Can you use Terraform in any way to help with migrating between providers?
Yes.
If you
Can you use it to migrate between providers? Yes, it's easy. So I pretty much did that, right? Because I had my existing setup at DigitalOcean, and I spent a couple afternoons just setting up my Azure account, and I could easily, well, just delete my old servers at DigitalOcean just using this. Is that what you were saying?
Thinking more about the config in Terraform. How similar are they?
Okay, so how similar are cloud providers really?
Yeah, really, because I was really hoping this to abstract the provider more away.
Yes.
But I didn't have to.
So I get your idea. Basically you have a workload that you want to run, and you don't really care where. That's it. And you pretty much want to run it with the cheapest provider because you want to save money, okay? And so let's say you have a virtual machine image and you just want to run it somewhere and you don't really care. You just want it to have it up and running. Okay. Now it turns out cloud APIs and cloud functionality, they're really similar, but not identical, okay? There's things like SLAs that vary. There's other concepts that are just different between them. They're similar, so it's quite easy to move from one to another one. It would take you a few days, let's say, but you can't do it in like 5 minutes. You can't do it in 5 minutes. You can do it in a couple of days, which is still much better than, you know, a couple of months or weeks or years or what we used to do. I haven't seen any questions from back there yet. No, okay. Any more questions? Yeah.
Regarding the Azure provider.
Yes.
specifically, do you know if it uses the Azure resource templates behind the scenes, or?
No. So the question is Terraform using what kind of API? How's this how does it work? So I haven't looked at the code really, but normally what you do when you implement a provider, you use a API binding. So that would be an SDK that knows the API of, let's say, Azure. And this particular Azure provider, there's actually two supported by Terraform. The legacy one, ASM, I've never used that, don't know much about it. But the new one, which I've been demonstrating, is using the, via the ARM API. Okay? So it's just doing HTTP stuff in the background. Okay. More questions? One more minute. Last one.
Okay. How do you expand this workflow if you have more than one person?
Yes. How do you expand it if you're more than one guy? So where I work, we're, well, at least 3 or 4 guys. And it turns out there is locking functionality in Terraform, right? As I mentioned, you can keep your state locked, and there's also enterprise features that you can buy from them in their enterprise offering. This is all free, by the way, right? Until now, this has all been free. There's an enterprise offering which allows you to do more collaboration kind of stuff, okay? But locking, you can get that for free too. Basically, the locking functionality that comes with the tool uses an atomic resource in the cloud, let's say, with or you could implement that yourself. It's not hard to implement locking. That's the very last question.
Do you have any kind of best practice using Terraform with DevOps in terms of, let's say, the actual building and deployment process? For example, let's say, as you mentioned, we should delete the hard drives after the build has completed those things. So do you have any kind of real recommendation that you can then transfer to our use cases?
Wow, that's a long question. So he was asking, how do you do this in real world, basically, and what are good practices? That would be, an hour talk, I guess. But we can come see me afterwards, and we'll talk more. Okay, thanks, guys.